For section 1.5, we are going to be talking about the greatest common factor, and just so that you have some vocabulary to go on, the greatest common factor, we a lot of times call that the GCF, and it means it's the biggest number that can go into two or more numbers evenly. Example 1, we're going to be finding the GCF using just lists of factors. The first thing we're going to do is find the greatest common factor of 24 and 40, and since we're going to be using lists this time, I think your best bet is going to be to set up the T-chart to keep things a little bit organized and find all the factor pairs that can go into each of those numbers. When you fill in those factor pairs, or you use the T-charts to figure it out, you should have something that looks like this. And then just to kind of finish that off, remember that's the work, you have to make your actual list, and we go in order from least to greatest usually. So we've got 1, 2, 3, 4, 6, 8, 12, and 24 are all the factors of 40, and you can go ahead and fill out your factor list for 40 here. And this is your factor list for 40, and if you were paying close attention, you might have even noticed I had a little mistake up there at first because I accidentally had a 40 listed there, and it should have been 2 times 20, so that you get 20 on there. And then you use these lists to find the greatest common factor by looking for the biggest number that they have in common. So you can see they have quite a few numbers in common, but the biggest one that they seem to have in common here is that there is an 8 on each list, because nothing bigger on either of the lists shows up on both of them. So that would tell us that the GCF, is 8. For example 2, we're going to keep finding the greatest common factor, but this time instead of using lists, we're going to do prime factorization using the skills we did in 1.4. So this time they want us to find the GCF of 12 and 56. So in order to be able to use prime factorization correctly, the first thing you're going to need to do is to use factor trees for both of these numbers and find your prime factorization. After you've completed step 1, which was to use those factor trees to find the prime factorization, remember that you're going to need to actually write those prime factorizations out, and this is where you're going to want to actually use the long version and not the exponents version, because the next step, it's going to be important to be able to see all of those prime factors. So the prime factorization of 12 is 2 times 2 times 3, and the prime factorization of 56 is 2 times 2 times 2 times 7, because those are all the prime numbers that we had left over here, or at the end over here. And then the next step there is going to be to start looking, but unlike in example 1 where you just picked the biggest one that they had in common, we're going to have another step that we have to include. So that extra step is to circle all of your common prime factors in pairs. So for instance, I have a pair of 2's, and in order for it to count as a pair, you have to have 1 on each list. They don't necessarily have to be on top of each other, but they do have to have 1 from each list. And then I have another pair of 2's over here, because again, I've got 1 on each list. And then I don't have any more common pairs because I just have a 3 up here and a 2 and a 7. So for instance, I could not have made a pair down here because those were both on the same list. But I have a pair of 2's and another pair of 2's. And so to kind of finish this off, what you're going to do is take each pair and use it one time, so a pair of 2's and another pair of 2's, and then you multiply those together for your final GCF. For the on your own problems, I'm going to leave all 6 of these problems here for you. You can certainly try them if you want to, but I'm only going to ask you to try a couple of them. So you'll try 1 and 2, and notice in your directions this time that you're supposed to be using the lists of factors for those 2, and then I'm also going to have you try 4 and 5, and for those you need to make sure you're using the prime factorization method. So make sure you go back to those notes and use the correct method in each of those so that you're getting practice in both. And then notice I'm leaving the kind of challenging ones here for you. These would require you to find the greatest common factor of 3 numbers each time. And we will certainly talk about that in class and even maybe give them a try at some point, but you're welcome to try them on your own, and I will plunk the answers down just in case you want to compare your answers if you choose to challenge yourself. And as you're working on these, I hope you're starting to notice that the lists use the list method works pretty well when you have slightly smaller numbers, and those prime factorization methods work really well as the numbers start to get a little bit bigger. Notice on this one how long that list starts to get, even at a number like 72. So like I said earlier, these lists work okay, especially if you keep them organized, but even these slightly bigger numbers like 72 definitely start to add up quite the list. For this one, notice too, you only had one pair of 5s, so we didn't have to multiply anything for that final step because there weren't any other pairs. We couldn't use the 2s as a pair or the 3s as a pair because they were in the same line, so the only pair we had was of 5s, and since there wasn't anything to multiply it by, your final greatest common factor is just 5. And on number 5, notice again, you've got pretty long lists of prime factorization here, but when all is said and done, the only thing you have in common between those two lists is one pair of 2s. So all these 2s are in one line, so you can't use them. The 3s are in one line, so you can't use them. So we just have one pair of 2s, and again, since it's just one pair, we don't multiply it together, we just use 1, 2, and that's our greatest common factor.